Hi, I'm Paul from Easy Composites, and in this video I'll be demonstrating how to produce split molds using tooling prepregs. Precision molds like these can then be used to go on to produce complex prepreg carbon fibre parts like this drone fuselage. An important aspect of their construction is their use of metal inserts which allow the mold sections to be accurately aligned and securely clamped together. And so we'll go through the use of these in detail. We'll look at the pattern preparation, how to position and dowel the mold clamping bushes, how to laminate them in, then, following an initial cure, how to extract the dowels before post-curing and finishing the final mold. If you were looking for some less niche composites content, then head over to the Easy Composites channel where you'll find lots of introductions and deeper dives into some more conventional subjects. Before we get into the details, let's quickly go over the basics to understand what we're trying to do here and why. This fuselage is the component that we want to produce. It's made from pre-preg carbon fibre, and so it needs high service temperature, low CT molds in order to produce it. Most typically, that's going to mean that your molds are going to be made from carbon fibre tooling prepreg. And because of the shape of this part, those molds need to be able to separate into separate components in order to release the component itself. Firstly, let's look at the patterns. These are used to form the molds. As tooling prepreg requires an elevated cure temperature, the material that you make your patterns from must also be compatible. Normally, that's going to mean that you're going to make them from epoxy tooling board like we have here. These patterns have been blocked out with EB700 epoxy tooling board, then CNC machined on a 3-axis router to final shape, had any machining marks removed by hand before being coated with S120 board sealer to get us to the final finish patterns that you see here. Unlike creating hand laminated split molds, where your pattern will typically be in one piece and then you attach temporary barriers onto them and form your parting lines against that, in the case of prepreg patterns, you will nearly always have those features machined in. The reason for that is that the temporary barriers simply won't withstand the heat and pressure that will be applied to them during a prepreg cure cycle. If you did want more information on how to design in the features like your parting lines and the flat areas for your clamping bushes, then we've got a video that covers that subject specifically, and I'll put a link to that in the description. The sections of a split mold need to be accurately aligned and securely clamped together. You could simply drill a hole through the flanges here and put a bolt through that, but if you were to do that, those holes are going to wear quite quickly and you'll soon have alignment issues. Also, if you over tighten the bolts, you can cause damage to your molds. So to overcome these problems, these molds feature split mold clamping bushes. Now, they're a little bit difficult to see buried inside the laminate here, but these bushes completely take care of your alignment and prevent any wear and damage to your molds. They're made right here in Stoke-on-Trent. They're precision machined, case hardened, and feature a grooved hexagonal profile which securely locks them into the laminate. They're available in both an M6 and an M8 variant and compared with an extractable dowel pin. The use of this we'll cover in a few moments. So let's now get into laminating the mold. I'm going to need some removable shuttering for these patterns. I'm cutting these from carbon fibre sheet on my CNC, but equally they could be profiled in any way from any material that can withstand the cure temperature. The purpose of these shutters is to create a flange at 90 degrees on the mould, and this wouldn't otherwise be possible to form as there's no draft angle on them. As ever, before we get into the lamination, we're going to need to apply a release agent onto the patterns. We're also going to need to apply release agent onto this shuttering as well. Whenever you have a multi-piece assembly like this, it's best to put the release agent on before you assemble it. That way, any resin that does bleed down between the gaps won't bond the pieces together. We're also going to be coating the dowel pins. Now, these are the extractable pins that are used to locate the clamping bushes onto the pattern. So I'll be applying 6 coats of CR1 chemical release agent to the patterns, the shuttering, and the pins. Once the final coat has dried, the shuttering can be assembled onto the pattern. This is done by drilling and tapping them out to M4 and then securing them in place with several bolts. The bushes are slid over the dowel pins and then these are inserted into the pattern in all of the locations. On these moulds, I also have some bushes mounted onto the sides, onto the shuttering here. This is to create some mounting locations that will allow a plate to be bolted onto the moulds that forms the wing root on the component. Now, to mount these, we don't have the depth in the shuttering to allow us to use a dowel, so instead we're just going to run a bolt straight through it and a nut on the other side. These patterns are now all ready for lamination. In theory, you could use a pattern made in this way with the bushes for a wet layup system like Unimold, or even a resin infusion using a high temperature epoxy. But in reality, for a mould of this size and detail intended to make pre-preg parts, then a pre-preg tooling system is going to be the obvious choice. I'm going to be using the out of autoclave XT135 prepreg, but the methods used here would apply equally to an autoclave system such as the XT180. Now, this video really isn't intended as a user guide on the XT135, so we are going to be going through the details quite quickly. If you did want more information on how to process this material, then I'll put a link in the description to a video that covers it in much more detail. Or you can head over to the Easy Composites website where you can download the full processing guide and find all of the materials and equipment you've seen used throughout this tutorial, including the tooling board, board sealer, pre-preg, mould bushes, bagging materials, and even the oven used for the cure, all available for shipping to most countries worldwide. The first step in the process is to cut some narrow 30mm wide strips at 45 degrees out of the surface ply, and then place these into all of the sharp corners. Then a patch can be laid over each of the clamping bushes. A wad punch is a great tool for creating the hole in the patch. The sides of the bushes are then wrapped with a ply of the 45-degree strip before the rest of the mould is laminated as normal. As with any tooling layup, this can be done in multiple pieces to make the lamination easier. We then repeat the exact same process with the second pattern. After laminating the full ply, they are debulked. This involves putting a layer of perforated release film, followed by breather, and then consolidating under full vacuum for 20 minutes to ensure good consolidation against the mould. The backing plies are now laminated in much the same way as the surface ply, but being heavier, they do take a little more work. For this small mould, I'm going to be doing a 1-2-1 layup, meaning one surface ply backed by two backing plies and then another surface ply to balance. On larger moulds, a 1-4-1 layup would be more typical. For optimal mould stability, it's also best practice to flip the backing ply upside down at the mid-plane and continue to laminate with the resin-rich side facing up. I've chosen not to do that here as it makes the laminating more time-consuming, and being such a small and contoured mould, it would have negligible effect on the accuracy. But for larger and flatter moulds, I would normally follow best practice here. Now that we have these parts laminated, we can get on and vacuum bag these and put them in for cure. A perforated release film is added, followed by a breather and then a vacuum bag. Full vacuum is then gradually pulled with careful manipulation of the bag to avoid any bridging. Wherever you have the pins, do pay particular attention as they will need a good amount of extra bag to fully surround them without risking puncturing the film. A drop test is performed before the moulds are loaded into the oven for the initial cure. This is done at a low temperature of 65 degrees C for several hours. If you're not familiar with tooling pre-pregs, this is really where they differ from regular ones. With the low initial cure temperature, it allows them to cure without causing excessive expansion on the pattern. After the initial cure, they can be removed from the oven and then have the bag removed. The next stage is to remove the dowel pins. The pins feature an M8 thread which a slide hammer can be attached to and used to extract the pins, using kind of a reverse hammer action. Another option is to use a T-handle, which is threaded and lock nutted onto the pin and then can be used to twist and pull the pins out manually. While these are probably the best methods, an alternative technique is to twist them out using a bolt, which if you're going to do, I would suggest using a locking nut on the thread to allow the pin to be separated after extraction. So you simply wind the bolt all the way in till it bottoms out, then wind it back half a turn before clamping the locking nut, and then twist firmly on the bolt while pulling it to extract the pin. It's also possible to use a cordless drill to twist and pull the pin, but do be careful to only use a very slow speed when doing this, otherwise the pin can get very hot and potentially damage the surrounding prepreg and tooling board. Once all of the pins have been removed, there's really nothing holding these moulds onto the patterns, and they remove very easily. The flashing is then removed from the flanges. The flanges are trimmed and the material around the clamping bushes is ground flush with the top of the bush. Doing this is necessary both to provide a flat surface to bolt against and also to remove any sharp flashes which could potentially burst a bag when the mould is used. These are the moulds as released from the patterns. I'm really pleased with what we've got at this stage. The next step for these is to conduct what's known as a post-cure. This is an elevated cure cycle that goes up to the maximum service temperature of the moulds and fully cures them. This is done off the pattern as that eliminates any problems that you might have with thermal expansion. It also, in the case of split moulds, allows us to firmly clamp these together during the cure. In doing that, they're going to remain accurately aligned, which means once they're fully cured, they're going to sit together perfectly. Whenever you're bolting a split mould together for post-cure, whether it's a pre-preg mould like this or really any other system, it's important to apply a thorough application of CR1 release agent to the mating flanges. Otherwise you can find that the temperature increase of the post-cure can soften the resin or gel coat sufficiently to cause untreated flanges to stick slightly to one another. With the release agent applied, the mould sections can be bolted together using the M6 bolts and dome nuts, which are size 4 and supplied with the MB6 bushes. The freestanding post-cure is conducted according to the processing guide for the XT135 tooling prepreg. It involves a very, very steady ramp rate up to the full cure temperature to avoid distortion. This is easily configured using the OV301's touchscreen controller. After the post-cure, you may notice that you have a small amount of print through caused by the elevated temperature of the cure. In order to remove this, you simply flat it down with an 8 or a 1200 grit abrasive and then apply 1 or 2 coats of S120 to restore the gloss. With the addition of these side plates, which have simply been machined from carbon fibre sheet, we now have a complete set of moulds. And by using the XT135 tooling prepreg and the MB6 bushes, we've managed to achieve a really high level of finish and accuracy. And these moulds can now be used to go on to laminate, vacuum bag and cure a whole batch of parts. Now, if you were interested in learning more about how to design in the features that you've seen on the patterns, so where to put in the parting lines, where to put in the flat lands for the dowel pins, then take a look at this video where I go through it in much more detail. If you have any questions or feedback, then post them in the comments below. Any questions about material selection or process for your tooling needs, then get in touch with our technical team who would be more than happy to help. From everyone here at Easy Composites, thanks for watching and see you next time.